Hi everyone, today we'll be taking a look at the Trig Table. So please be sure to write down the FLT. Given a Trig table, I will be able to fill it out to help me find trig values. So today we'll be filling out this thing called the Trig Table, which will help you find different trig values. So with this table, you'll easily be able to find values like what is sine of 45 degrees, or like what is tangent of 315 degrees. So here's the trig table we'll be working with. So if you haven't had the chance, please copy this down in your notebook, or if you have a printer, feel free to just print it out as well. The original file is posted on Canvas. All right, so there honestly seems to be like a lot going on with this table, but we'll break it down part by part, and we'll work through a lot of the chart values together. So we're going to start off by converting all these degree values, so all these angle values we see here, into radians. So we're converting from degrees to radians, which is a topic we covered a few weeks ago, but I'll quickly review over it again. So let's first focus on the quadrantal angles. These are the angles that lie either on the x or y axes, and remember they're in increments of 90 degrees. So we'll focus on converting these quadrantal angles from degrees to radians. So we know our conversion factor, 180 degrees, equals 1 pi radian. So we fill that out. We also know that 0 degrees would be the same thing as 0 radians. And since 360 degrees is double 180 degrees, the radian value would be doubled as well. So 360 degrees converts to 2 pi radians. Now let's take a look at 90 degrees. That's half of 180 degrees. So in radians, that'll be half of pi, or pi over 2. And then 270 degrees is 180 degrees plus that extra 90 degrees, which would convert to pi and a half, which is 3 pi over 2. And in general, overall, if you have any questions about any of these steps, definitely let me know. So we've converted the quadrantal angles from degrees to radians, but what about all the other angles in between? Let's look at a few of these angles together. Let's start off with 30 degrees. So we're going to convert 30 degrees into radians. So what we're going to do is start off with 30 degrees, and we have our conversion factor. So we want to end up with radians, and we're starting with degrees. And we know that 1 pi radian equals 180 degrees. So I noticed that the degrees will cancel out, so we're left with 30 pi, and I'm not going to write the radians, but technically 30 pi radians over 180. I can simplify this by dividing both the numerator and denominator by 30. So when we simplify it, this becomes pi over 180 divided by 30, which equals 6. So 30 degrees converts to pi over 6 radians. So we were able to convert from 30 degrees into pi over 6 radians. Now let's take a look at 45 degrees. So we start with 45 degrees, and we multiply by pi radian, so 1 pi radian over 180 degrees. The degrees are going to cancel out. So we have 45 pi over 180. And I just happen to know that the greatest common factor here is 45. So I'm going to divide both the numerator and denominator by 45. I find that this simplifies to pi over 4. So 45 degrees converts to pi over 4 radians. But it's okay if you don't know the greatest common factor off the top of your head. You can always break it down step by step, which we'll be doing in these following few examples. So let's look at 135 degrees. We're going to convert this into radians. Okay, so we have our conversion factor. The degrees cancel out, and we get 135 pi over 180. But honestly, off the top of my head, I don't know what the GCF is. So what I'm going to do is divide both the numerator and denominator by something I do know is a factor, so by 5. And this simplifies to 27 pi over 180 divided by 5, which would be 36. I can further simplify this by dividing both numerator and denominator by 9. And this simplifies to 3 pi over 4. So even if you don't know the greatest common factor, you can always break it down step by step. 135 degrees converts to 3 pi over 4 radians. And next, 300 degrees, let's convert that into radians. The degrees cancel out. And so we have 300 pi radians over 180. I know that these are both divisible by 10, so let's do that first. And I get 30 pi over 18. 30 and 18 are both divisible by 6. And I get 5 pi over 3, which is fully simplified. And so I know I'm kind of going quickly through these examples. Part of it being because we've seen these topics before. This is more just like a combination of previous topics we've seen, but also because I don't want to make this video like 2 hours long. That would be dreadful. But do remember, you can pause the video at any time. And you can also review topics as needed by going to past videos or asking me any questions. So we just figured out a few values going from degrees to radians. So we found out that 30 degrees written in radians would be pi over 6. So here, pi over 6. And we also converted 45 degrees into radians, which was pi over 4. And we also covered a few more. So like 135 degrees, that's 3 pi over 4. And we worked on one more together, 300 degrees. That ended up being 5 pi over 3 radians. So go ahead, pause this video right now and convert the other values into radians, and then press play when you're ready to compare answers. So here are the remaining angles converted from degrees into radians. Compare them with the values you got, and then let me know if you have any questions. So now that we converted from degrees to radians, we got that out of the way. Let's take a look at the quadrantal angles again. So we're going to look at the trig values of these quadrantal angles, which is actually the most recent topic we worked on. So for example, we're going to find values like sine of 0 degrees and like tangent of 180 degrees. So here for the sine and cosine values, we simply use our calculator. So feel free to use your phone calculator or my favorite Desmos calculator. So sine of 0 degrees is 0, sine of 90 degrees is 1, sine of 180 degrees is 0. Again, these are values that I just found by plugging them into the calculator. And then cosine I can similarly find by using my calculator. And then these will help us find the remaining values as well. Okay, so just writing them out. Okay, so if you remember from the previous lesson, we can find the tangent values by putting sine over cosine. So for example, tangent of 90 degrees is 0 over 1, which simplifies to just 0. Tangent of 90 degrees would be 1 over 0, which is undefined. Tangent of 180 degrees is 0. Tangent of 270 degrees is undefined. And tangent of 360 degrees is 0. So we figured out the sine, cosine, and tangent values for these quadrantal angles. So what's the relationship between these three functions and the remaining three trig functions? They're reciprocals of each other. So like tangent and cotangent are reciprocal functions of each other. And we also have the cosine function and secant function. And the last pair, sine and cosecant, are reciprocal functions of each other. So we can use this idea to find the remaining values. So tangent and cotangent are reciprocals of each other. So I talked a little more about this in the previous video about quadrantal angles, but the reciprocal of 0 is undefined. So cotangent of 0 degrees is undefined, and the reciprocal of undefined is 0. So cotangent of 90 degrees would be 0. And we'll just fill out the other values as well. And then next we'll fill out the values of secant, which are the reciprocals of the cosine values. And so remember that the reciprocal of 0 is undefined. The reciprocal of -1 is just -1. And then filling out the rest as well. Definitely be careful about the positives and negatives here. And lastly, we're going to fill out the values for cosecant. So the reciprocal of 0 is undefined. The reciprocal of 1 is just 1. And just filling out these other values as well. Again, not really going through these in detail because we did just go over these in last week's topic. But if you have questions, again, pause, replay, let me know. So now we've filled out all the trig values for the quadrantal angles. So we know anything from sine of 0 degrees to, let's say, secant of 2 pi radians. So we've filled out all the trig values for the quadrantal angles. Now let's take a look at all these other angles in between. So all these other values, so all these other angles within quadrants, are actually in increments of like 30 degrees or 45 degrees. And where have we seen these numbers before? I know it's been a while, but hopefully these vaguely remind you of special right triangles. So if you have your notes for special right triangles, awesome. If not, definitely copy down these two triangles. On the left side, we have the 30, 60, 90 triangle. The sides of special right triangles actually fit into a certain type of pattern. So for the 30, 60, 90 triangle, the ratio of the sides is always the short leg being 1, or a multiple of 1, the long leg being the short leg times radical 3, or simply in this case, we'll just leave it as radical 3. And the hypotenuse is double the length of the short leg. So in this case, just 2. And then for the 45, 45, 90 triangle, if the legs each measure 1, then the hypotenuse has a length of radical 2. So just remember these ratios when you see special right triangles today. So for the 30, 60, 90 triangle, we have a ratio of 1 to radical 3 to 2. And then for the 45, 45, 90 triangle, we have a ratio of 1 to 1 to radical 2. And we also had this acronym ASTC, or All Students Take Calculus. So pause this video real quick and try to recall what this acronym tells us. So what is ASTC? And then press play when you think you have a good idea. So ASTC tells us which trig values are going to be positive in each quadrant. So in quadrant 1, all trig values will come out positive, whereas in quadrant 2, only sine and its reciprocal, cosecant values will come out positive. And in quadrant 3, we have tangent and cotangent values becoming positive, but everything else would be negative. And then lastly, in quadrant 4, only cosine and secant values would be positive. So ASTC, All Students Take Calculus, is a good way to remember which trig values would be positive in each quadrant. So with that in mind, now let's tackle each of these angles. Let's start off with 30 degrees or pi over 6 radians. So we're going to fill out the trig values for the angle 30 degrees. To find these trig values, let's first draw out a reference angle for 30 degrees and create our reference triangle. So 30 degrees is probably somewhere around here. It's definitely in quadrant 1. And we would set up our reference triangle like this. This is a right angle. And here we have 30 degrees. And since we have 30 degrees and 90 degrees, the remaining angle would be 60 degrees. If you have questions about this, definitely let me know. And in general, for these problems, you want to imagine that you're standing at the center of the circle, so somewhere here. And we'll be able to evaluate trig values based on where we're standing, which is basically the origin. So I drew the triangle, the reference triangle by itself so that it's a little easier for us to see the different side lengths. And on the right, I put all just to remind me that we are in quadrant 1, so all trig values are going to turn out positive here. So here I have a 30, 60, 90 triangle with the short leg having a length of 1, the long leg having a length of 1 with the extra radical 3, and the hypotenuse having a length of 2. And based off of this, I will be able to find each trig value. So let me first label each part. This is our hypotenuse. And based off of where we're standing, this is our opposite side. And lastly, our adjacent side. So from here, we can use the idea of SOHCAHTOA to find the different trig values. So we're going to start off with finding sine of 30 degrees. And actually, let me write SOHCAHTOA up here just to remind ourselves how to find each trig ratio. So sine of 30 degrees is going to be the opposite side over the hypotenuse. So 1 over 2. And since we're in quadrant 1, each trig value will be positive. Next, let's find cosine of 30 degrees, which is going to be the adjacent side over the hypotenuse. So in this case, that's radical 3 over 2. And again, this is positive as well. Going on, tangent of 30 degrees equals the opposite side over the adjacent side, which would be 1 over radical 3. But remember, we want to rationalize the denominator, so this would turn into radical 3 over 3. And again, this is positive. So we've found the values for the first 3 trig ratios. Now let's find the remaining 3 using the idea of reciprocals. So the reciprocal of the sine function is the cosecant function. So let's go ahead and find cosecant of 30 degrees. The reciprocal of 1 over 2 is 2 over 1, which simplifies simply to 2. And remember, it's positive. Next up, let's find secant of 30 degrees, which will be the reciprocal of cosine of 30 degrees. So what's the reciprocal of radical 3 over 2? It's going to be 2 over radical 3, but remember to rationalize the denominator. So we have 2 times radical 3 over 3, and this is positive as well. And lastly, we're going to find cotangent of 30 degrees. So in this case, I'm going to focus on the 1 over radical 3 part just because it's a little easier to find the reciprocal. So the reciprocal of 1 over radical 3 is radical 3 over 1, which is simply just radical 3. Again, positive. So here, all the trig values are positive because we're in quadrant 1. And to help you find trig values, remember the relationship between the different trig ratios and how they're reciprocals of each other. Also, the fact that sine of 30 degrees equals positive 1 over 2 means that sine of pi over 6 radians also equals positive 1 over 2, because 30 degrees converts to pi over 6 radians. So I know this is a lot of information to digest, but if you feel overwhelmed, just remember that you can pause the video at any time, and also that you've seen each of these topics separately actually, and now we're just combining the ideas. And then now let's fill out this table for 30 degrees or pi over 6 radians. So sine of 30 degrees is positive 1/2. And then cosine of 30 degrees is positive radical 3 over 2. Tangent of 30 degrees is positive radical 3 over 3, and then so forth. So we're just going to fill out the table with the values that we just found. Also, I added the highlighting colors just to show the reciprocal relationships. So again, these are the values that we just found looking at that 30-degree reference triangle. And then up next, we're going to find the trig values for 45 degrees. So this column right here. So here, once again, I have my unit circle. And from here, I'm going to draw this 45-degree angle to create our reference triangle. So my reference triangle looks like this. And so my remaining angle measures 45 degrees. And again, I'm going to be placed at the center of the circle. So here is my reference triangle, and it's actually a special right triangle, a 45, 45, 90 triangle. So I'm going to write out the side lengths. So the legs both have a length of 1, and the hypotenuse would have a length of 1 times radical 2, or just radical 2. So this is my hypotenuse based off of where I'm standing. I have my opposite side right here, and also my adjacent side, the side right next to me. And based off of this, we can set up our trig ratios. Sine of 45 degrees equals the opposite side over the hypotenuse, which in this case is 1 over radical 2. But we want to rationalize the denominator, so this becomes radical 2 over 2. And again, since we're in quadrant 1, everything's going to be positive. And this tells me that sine of pi over 4 radians also equals positive radical 2 over 2, because 45 degrees converts to pi over 4 radians. And so now let's keep going to find the other trig values. Cosine of 45 degrees is going to be the adjacent side over the hypotenuse, which is 1 over radical 2. So actually the same as sine of 45 degrees. We rationalize the denominator and get positive radical 2 over 2. So sine of 45 degrees and cosine of 45 degrees are the same. We're also going to find tangent of 45 degrees, which is going to be the opposite side over the adjacent side. This is just simply going to be 1 over 1, which is just 1. So tangent of 45 degrees equals positive 1. And we're going to find the remaining 3 trig values using the fact that we have reciprocal functions. So let's start off with cosecant of 45 degrees. So when taking the reciprocal, I'm actually just going to focus on this 1 over radical 2. And so the reciprocal of that would be radical 2 over 1, which is simply positive radical 2. And then secant of 45 degrees. Similarly, we take the reciprocal of 1 over radical 2, which is just radical 2 over 1. So positive radical 2. So notice how cosecant of 45 degrees and secant of 45 degrees are equal to each other. And then we have one more trig value to find. So cotangent of 45 degrees. The reciprocal of 1 is simply 1, but I'll write it out, 1 over 1. That's positive 1. So once again, by setting up my reference triangle, I was able to find the trig values for 45 degrees. So let me fill out this table for the column of 45 degrees with the trig values that we just found. I'm going to speed this up a little bit just because this video is getting quite lengthy, but make sure you have these values down on your own table as well. And now let's focus on the last angle in quadrant 1, so 60 degrees or pi over 3 radians. We're going to start off by creating our reference triangle. So 60 degrees, probably somewhere around here. You don't have to be like 100% accurate. Just be able to sketch your reference triangle. We have a 60-degree angle right here, which leads to this reference triangle. So we're working with the 30, 60, 90 triangle again, but notice how it's a little different compared to when our reference angle was 30 degrees. Once again, I am standing at the center of the unit circle. So here I have my reference triangle, which creates a 30, 60, 90 special right triangle. The short leg has a length of 1. The long leg has a length of 1 times radical 3, or just radical 3. And the hypotenuse has a length of 2. Make sure you correctly label each side depending on where you're standing. So we have the hypotenuse, opposite side, and adjacent side. So we can now set up our trig ratios. So sine of 60 degrees is the opposite side over the hypotenuse. So in this case, that would be radical 3 over 2. And we're still in quadrant 1, so this is positive. Up next, cosine of 60 degrees is the adjacent side over the hypotenuse. So that would be 1 over 2. Again, positive. And then tangent of 60 degrees is the opposite side over the adjacent side. So that would be radical 3 over 1, which is simply positive radical 3. And then let's find the remaining 3 trig ratios. Cosecant of 60 degrees is the reciprocal of sine of 60 degrees. So that would be 2 over radical 3, but remember to rationalize the denominator. So we have 2 times radical 3 over 3, and it's positive. Next, secant of 60 degrees is the reciprocal of 1 over 2, so 2 over 1, which is 2, positive. And lastly, let's find cotangent of 60 degrees. So let's take the reciprocal of this. We have 1 over radical 3. And if we rationalize the denominator, that becomes radical 3 over 3, and once again, positive. So here, all of our trig values are positive because we're still in quadrant 1. But for the upcoming examples, you'll notice that some of the trig values will be negative. So once you fill out the table for this column of 60 degrees, let's actually move on to quadrant 2 and look at 120 degrees. We're now in quadrant 2, which means that only sine and cosecant values will be positive. So let's start off by drawing our reference triangle for 120 degrees. 120 degrees is somewhere around here. So this angle is 120 degrees. And the reference triangle is created by the terminal side and the x-axis closest to the terminal side. So it'll look like this. And then let's figure out the angle measures. This reference angle right here measures 60 degrees because 120 degrees plus 60 degrees creates this half circle of 180 degrees. And the remaining angle is 30 degrees. So here I've created the reference triangle, and this lies in quadrant 2. So here's my reference triangle. And look at kind of how the direction changes where I'm standing and what the triangle looks like, but it's still the same idea. And I put the actual angle we're working with, 120 degrees, in light gray to remind you that although the reference angle is 60 degrees, what we're working with is actually the trig values for 120 degrees. The short leg measures 1, the long leg has a measure of radical 3, and the hypotenuse a measure of 2. And make sure you correctly label all 3 sides. Okay, so let's start off by finding sine of 120 degrees. Opposite over hypotenuse, so that's going to be positive radical 3 over 2. And now that we're in quadrant 2, only sine and cosecant values will be positive. So cosine of 120 degrees is going to be negative the adjacent side 1 over the hypotenuse 2. So negative 1 over 2. And tangent of 120 degrees will also be negative. It's the opposite side over the adjacent side. So negative radical 3 over 1, which is simply negative radical 3. And now let's take the reciprocals of these values. Cosecant of 120 degrees would be positive 2 over radical 3, which would become positive 2 times radical 3 over 3. And then secant of 120 degrees, this is going to be negative 2 over 1, or simply put, negative 2. And then cotangent of 120 degrees equals negative 1 over radical 3, which is negative radical 3 over 3. So here, only sine and cosecant values were positive. Everything else was negative because we're in quadrant 2. And so I'm going to write in the values for 120 degrees. And some of you might start seeing a pattern, but don't worry if you don't. It definitely took me a while to figure out the pattern, and sometimes the pattern can be confusing. So until you're really confident with the pattern, you can always just use the idea of reference triangles for each of these angles. And so I'm going to skip a few values here. Let's move on to 225 degrees, which lies in quadrant 3. So 225 degrees is going to be in quadrant 3, right here. And so I'll create my reference triangle in this quadrant. So here I have my 225 degree angle, and I'm able to create my reference triangle. And our reference angle here measures 45 degrees, which means I have a 45, 45, 90 triangle. Again, if you have questions about how to find reference angles, let me know. And so we're in quadrant 3, and I'm standing still at the center of the circle, so right here. So here I've already set up my reference triangle along with its side lengths. Here I have a 45, 45, 90 triangle. So now let's find each of the trig values for 225 degrees, or in other words, 5 pi over 4 radians. So sine of 225 degrees, this is going to be negative since we're in quadrant 3. So we have negative 1 over radical 2, which if we rationalize the denominator, we get negative radical 2 over 2. And then cosine of 225 degrees will also be negative. So this is going to be negative 1 over radical 2. Oh, guess what? The same as sine of 225 degrees. And then tangent of 225 degrees is going to be positive since we're in quadrant 3. So we have positive 1 over 1, which is just positive 1. And next, let's find the remaining 3 trig values. So cosecant of 225 degrees is going to be negative. And so I'm taking the reciprocal of this. So I get negative radical 2 over 1, which is just negative radical 2. And the same thing for secant of 225 degrees. Same thing, negative radical 2. And lastly, cotangent of 225 degrees will be positive, and the reciprocal of 1 is just 1. So since we were in quadrant 3, now only tangent and cotangent values are positive. So here I'm going to write in these values for 225 degrees. And then let's look at one more angle together, 330 degrees, which lies in quadrant 4. So we start off by drawing a 330 degree angle, which lies in quadrant 4. Our reference angle has a measure of 30 degrees. And from here, we create our reference triangle. So here I have my reference triangle set up for the angle 330 degrees. So let's find each trig value. So we're going to start off with sine of 330 degrees. Opposite over hypotenuse, and it's also going to be negative since we're in quadrant 4. So negative 1 over 2. Cosine of 330 degrees will be positive because cosine functions are positive in quadrant 4. So we have positive radical 3 over 2. And then tangent of 330 degrees will be negative. So we have negative and then the opposite over the adjacent. So negative 1 over radical 3, which becomes negative radical 3 over 3. And then let's find the remaining 3 trig values, starting with cosecant. So cosecant of 330 degrees is -2 over 1, which is just -2. Secant of 330 degrees equals +2 over radical 3, which becomes +2 times radical 3 over 3. Then lastly, cotangent of 330 degrees. Let's take the reciprocal of -1 over radical 3. So that's negative radical 3 over 1, or just simply negative radical 3. We found all 6 trig values for the angle 330 degrees, or in radian form, 11 pi over 6 radians. So let's fill out the trig values for 330 degrees. And I know I usually don't say homework, but your homework is to fill out the rest of the values using either reference triangles, or if you've figured out the pattern, feel free to use that pattern. And so when you submit your notes, make sure you've completed the entire table first. So just a very quick review of quite the lengthy lesson. Use the idea of reference angles, trig ratios, and signs of trig ratios to help you fill out that trig table. And then please remember to fill out the entire trig table before submitting your notes on Canvas.